So for this unit, we are going to do trig equations and identities. We'll have 4 learning days. So today, Thursday, and then the Tuesday after spring break and the Thursday after spring break. So those will be our 4 learning days, and then study guide and test. So your test, if you like to go ahead and write it down, is on April the 7th. April the 7th is going to be your test over trig equations and identities. Okay. So we're going to start out today with the more basic equations, ones that we don't have to do a whole lot of work before we use the unit circle. We'll increase the steps that we have to use on Thursday, and then we'll introduce identities when we come back from spring break. So more of just like algebra with trig stuff on Thursday. Raise your hand if you are missing Thursday because you have to go down to Hot Springs. Oh, yeah, Alan, you got to be there, don't you? Yeah. I will have the lesson recorded for you guys as well, just letting you know that. Okay. So if you have questions with that after you've watched the video for the lesson on Thursday, just let me know. I think there's just like 4 types of problems that you have to do that you do a little bit before what we're going to do today. So it's like some factoring and some, mostly just factoring actually, now that I think about it. But it's with trig equations, so it might be a little different than what you're used to doing. So what we're going to look for is we have 2 types of problems. If you've noticed, some of them say to solve the equation from 0 to 2 pi. And some of them say to solve the equation finding all of the solutions. So there's a difference in the way you answer your problems if it's from 0 to 2 pi versus all solutions. So from 0 to 2 pi just means going once around the unit circle. So if they ask you a question like this, sine theta is -3 pi over 2. You want to find the angles where sine is -3 pi over 2. So you look at your unit circle, you find that, and you write down all the times between 0 and 2 pi that sine is -3 pi over 2. So I've got my unit circle pulled up. We can go ahead and do that real quick. Is sine the x or the y?
Y.
The sine is the y. So I'm going to go down, look at my unit circle. I'm looking for a y value of -√3 over 2. And it looks like I am here and here, right? Both of those have a y value of -√3 over 2. So I write them both down. So if it says to find the solutions between 0 and 2 pi, you look around your unit circle, find when sine equals those numbers, and those are your solutions. Very similar to inverse trig functions. Doesn't this seem just like that? Like this is the sine, you find the angle. Yeah, it is. So that was 4 pi over 3 and 5 pi over 3. And that's the answer. Y'all think it's going to stay this easy the whole time?
No.
No. You've seen the problems, haven't you? You just wrote them down. It's not too bad today, though. I tried to break up the equations. I normally do all the stuff we're doing today and Thursday in one day, but I wanted y'all to be able to spread it out, especially if you're missing Thursday. All right, so for number 2, we want to figure out when sine is -√2 over 2. So I'm going to go ahead and show the unit circle again on the screen if you don't have one. And I want you guys to write down the times, go around the unit circle, write down when sine is -√2 over 2. I guess I need to shrink my unit circle so y'all can see the whole thing. Shrink, shrink. Can you see almost the whole thing? No. Now I made it a unit oval instead of a circle. There we go, kind of. All right, so find the 2 times that sine is -√2 over 2. Write those down. Go get them.
Yes.
So we have 5 pi over 4. And what's the other one?
7 pi over 4.
And 7 pi over 4, right. And it gives you a hint of whether or not you want to write your answers in radians or degrees based on if they tell you from 0 to 2 pi, they want you to do radians. If they say from 0 to 360, then you're going to write the degree down. Okay, does that make sense? They'll normally tell you also in the problem, but if you're unsure. So that was 5 pi over 4 and 7 pi over 4 would be our answer for that. Okay. So in our next type of problem, they're going to ask us to write down all of the solutions, like every time it ever equals a specific number. So for that, we have to think about what is happening on our unit circle. Because remember, once we go around the unit circle, doesn't it just repeat again, and then again, and then again? So if we're looking for when cosine is -1, which that is right here, right? That's when our x value is -1, cosine is -1 here at 180 degrees. The next time we go around, it's going to also be -1 for the cosine. And we go around again, and then we go around again, and then when we go around again. So to figure out all of the solutions, you find the 1 or 2, sometimes there's 2 times that it happens on your unit circle. So in this case, cosine is -1 at, we'll double check, cosine is -1 at pi. But we want to tell the person that's looking at our paper or whoever it is that we know that every time around the circle, it's going to also be at pi. So if we go all the way around the circle again and again and again and again, it's also at pi. How much is once around the circle?
360.
360, and in radians, that is 2 pi. So what we're going to write is after we write our answer, we're going to add plus 2 pi n, and n stands for an integer. So it could be plus 2 pi times 1 for once around the circle, or 2 for twice around the circle, or 3 or 4 or 5. So this is telling the person that the first one is pi, but to get every solution that's ever going to happen, you just add 2 pi to that over and over and over again. So when they're asking for all solutions, you're going to add a plus 2 pi n to your problems where your period is 2 pi. Or to get to the next one, you have to go all the way around the circle. Because the period, remember when we talked about our graphs, it repeated after 2 pi. So the things that had periods of 2 pi were sine, cosine, secant, and cosecant. For all of those problems, you're going to add plus 2 pi n because our period is 2 pi. It repeats after that. What did not have a period of 2 pi for the graphs?
Tangent, cotangent.
Tangent and cotangent, and their period was just 1 pi, right? After a single pi, you're going to repeat. So you only have to worry about, for tangent, we're only looking at the top half of the circle. We only care about the top half. And we're just going to say plus pi n instead of 2 pi because the period is pi. So the period is pi. So when we do our adding for all solutions, you just put plus pi n. So for cosine, sine, secant, and cosecant, it's 2 pi n because it repeats every time around the circle. And tangent repeats every half around the circle. So you only have to look at the top part of your unit circle for tangent. You don't have to do the whole thing because that repeats every pi. So it's going to show up in the bottom. You're going to go ahead and get that when you write plus pi n. All right, so let's look at when is tangent -1 from the top of our circle. Remember, tangent is y over x. So for it to be -1, do you guys see where it is right here? 3 pi over 4. Because root 2 over 2 divided by negative root 2 over 2 is -1. So that's when tangent is -1. Dividing the y and the x. So this answer would be 3 pi over 4 plus pi n. because the period for tangent and cotangent is just pi, so we just put pi in. For the other 4, plus 2 pi in, if they ask for all solutions.
And you said tangent equals y over x?
Yeah, tangent's y over x. Mm-hmm.
Can you explain how we got the answer to number 3 again?
Number 3?
Mm-hmm.
The pi part?
You like the whole thing.
The whole thing? Okay, for the pi part, we looked at cosine was -1. So if you go on here, cosine is -1 at pi, because the x is -1 at pi. But they're asking for all solutions. So if you go back around the circle another time, cosine is still going to be -1. We've just added 2 pi to it. And then we could add another 2 pi, and it's still -1. If I was at 3 pi, I would be here, or 5 pi, or 7 pi. It would still be in the same place. So writing that 2 pi in is going to include all of those cycles around the circle where you hit that same spot. So when they say all solutions, they just want you to know that you are hitting that same spot every time you go around the circle.
And can you show me how you found the answer to 4, the 3 pi over 4 plus pi n? I know how you got the pi n part, but not the 3 pi over 4.
This is y over x for this one. So root 2 over 2 divided by negative root 2 over 2. When these two numbers are the same, right?
It's
You
negative.
have a 1 and then there's a negative in the front. So -1.
Okay.
You kind of have to divide these y over x in your head to find the one that you're looking for. So you get those. Okay, so all solutions, 2 pi n for these 4, pi n for tangent and cotangent. All right, cotangent as well. That's if you're doing it in radians. 2 pi is the same as 360 if you're in degrees, and pi is the same as 180 if you're in degrees. So if you want to put that underneath, that if we were in degrees, I can put that down here. Degrees would be 360 in for these 4. And it would be 180 in for cotangent and tangent. Okay, now most of the rest of what we're going to do, one question, we do something at the end of this, but most of these are just getting the trig function by itself, so doing some dividing or subtracting and then solving from there. So before, the trig function was already alone, and these you want to get it by itself first, and then we'll solve the problem. So this question says from 0 to 2 pi, so I'm just going to look all the way around the unit circle. I don't have to do anything fancy with plus pi's or plus 2 pi's. So on number 5, is cosine by itself yet?
No, but if you add,
We got -2 times cosine, so we're going to divide by -2 on both sides because it was multiplied by it. And 2 over -2 is -1. So we're looking for when is cosine -1, and then we just do that one. Cosine is -1 at pi. So theta is equal to pi. I haven't been putting theta equals in these other ones. I probably need to. Theta equals, because that's what we're finding. Okay, go back down so you can see it. So we looked at our unit circle, because we just did that one. I didn't realize I had the same one on there. All right, and our next one, I've got 2/5 times cosine is equal to root 3 over 5. Is cosine by itself? Nope, we need to divide by 2/5. That'll cancel out. So cosine is root 3 over 5 divided by 2 over 5.
On number 5, why didn't you put the n after pi?
Just said from 0 to 2 pi. If they say all solutions, you put that on there.
Thank you.
Mm-hmm. All right, and let's just do this dividing out to the side just to make sure that we're good. So that's root 3 over 5 times. Remember, you flip the second fraction over and you're dividing fractions. What's going to happen with these two 5s? They're going to cancel. And that's just root 3 over 2. So we're looking for when cosine is root 3 over 2. Cosine is the x. So when x is root 3 over 2, that is here, right? I bet there's another one right here. Okay, so pi over 6 and 11 pi over 6. The difference between this and your inverse trig functions is your inverse trig functions, you were only finding one of these. Like cosine, remember, was limited to the first two quadrants. Sine and tangent were limited to the first and the fourth. But for this, you're looking around the entire circle. So everybody good on number 6? Divide. Do your dividing out to the side if you need to. Do y'all know this? I think we've kind of talked about this. If you have a fraction over a fraction and the denominators match, if you don't want to do your dividing out to the side, you can cancel your denominators. They're always going to cancel out if they're the same. So root 3 over 5 and 2 over 5, you could go ahead and get rid of your 5s here. Did y'all know that? Okay. All right, only a couple left. Thumbs up, this going okay? Okay. Oh, another unit circle. All right, on number 7, we are not by ourselves yet. So what do we need to do to get the cosine part by itself? Add 5, good. So 1 is equal to cosine of theta over 2. So this one's going to be a little bit different because once we solve it, we're going to figure out when cosine is 1. We're finding theta over 2 instead of just theta. So once we figure out what our angle is, we have one more step because we want to get theta by itself. So I'm going to put parentheses around that just so I remember it. Are we going from 0 to 2 pi, or are we finding all solutions?
All solutions.
All solutions. Okay, so we're going to have to write our plus 2 pi in. We're looking for when is cosine 1. Don't worry about the theta over 2 right now. So when is cosine 1? Cosine is 1 at 0, right? I'm going to say 0 plus 2 pi n. And that is equal to not just theta in this problem because we have this over here. That is equal to theta over 2. Okay, so is theta by itself? Right now? No, it's not by itself. What would we have to do to get it by itself? How do you get rid of divide by 2?
Multiply.
You're going to multiply, yeah, multiply by 2. So for this, normally we don't have a 0. We'll probably have like a number, like pi over 6 or pi over whatever. You're going to multiply the 2 times both of these things. So you're going to say times 2, and then theta will be by itself. I'm going to put it in the parentheses just so if you have a problem where it's not just a 0 there. So we'll distribute it. That's still 0. Plus, but instead of 2 pi n, what's it going to be? What's 2 times 2 pi n? Yeah, 4 pi n. Your answer choice wouldn't put the 0 plus because, you know, 0 plus doesn't really matter. It would just have the 4 pi in there. So if you have an operation with your theta, you hold off on that till the very end. You find the angles you need to find, you do all you need to do, and then at the end, once you have it written down, then you get rid of whatever number is next to your theta.
So how did you get to 2 pi n?
Because it said all solutions. And it
But
was
I'm saying, how did you find the 2 pi?
right here.
Yes.
It's because they're asking for all solutions, and it was a cosine problem. So anytime they say all solutions, and it's sine, cosine, secant, or cosecant, after you get your answer, you put plus 2 pi in every time that it says all solutions for those four.
So we didn't have to look at the unit circle for this one?
Yeah, we did. We looked at it and we said 0 was when cosine was 1. Because cosine's the x. Cosine is 1 at 0.
Oh,
So we put 0 for that part. So that's where we got the 0 part, and then we did the plus 2 pi in because it asked for all solutions.
yes, ma'am.
All right. And also, I don't like how they don't put parentheses around these. So I like to put them in parentheses so I know not to worry about it right now. So on number 8, what needs to go away before we can figure out our angle? The 8, right? We're going to divide by 8. They like to come up with creative ways for you just to simplify a root 3 over 2 or to simplify a 1/2 or a root 2 over 2. So 4 over 8 is the same as 1/2. So we're just looking for when is sine negative root 3 over 2. So sine negative root 3 over 2. I'll go back to my unit circle. Sine is y. Negative root 3 over 2 is 5 pi over 3 and 4 pi over 3. 5 and 4 pi over 3. And in that case, you need to write out 2 things because we have 2 answers. So 2 theta, 5 pi over 3 and 4 pi over 3, those came from the unit circle. It said all solutions, so what do we need to add to both? Plus 2 pi n. Is the theta by itself yet? Nope. So what do we need to do? We need to divide everything by 2. But what's that the same as multiplying by? Because we've got fractions, so it might be helpful for us to think about that. It's dividing by 2, but also multiplying by what? If you divide by 2, that's the same as multiplying by 1/2, right? That'll make it easier for us with our fractions. So we're going to divide everything by 2, but that's the same as multiplying by 1/2. Divide everything by 2. So theta is 1/2 times 5 pi over 3 plus 2 pi n. I just like the 1/2 when you're multiplying by the fraction instead of trying to think about that and dividing by 2. It's easy to see how you get the next fraction that we're going to write, but I just like to do the 2 there as well. So 1/2 times 5 pi over 3 is 5 pi over 6, is the 2 and the 3 multiply together, and the 1 and the 5 pi multiply together. And 1/2 times 2 pi over n is just pi n. Not over n, just 2 pi n. You can see that here too if you like to do the dividing part, but that's just going to be pi n. And then 4 pi over 6 plus pi n. Yep, dividing by something is always the same as multiplying by its reciprocal. Sometimes that's helpful when you have fractions to deal with. You only have a few of these on here. It's just that you need to remember if there's something with the theta that once you find your angle, then you need to get rid of whatever that number is. So if it was a divide by, you need to multiply by that number. If it was already multiplied, you divide by that number. Okay. We all right if there's a number on the inside? All right, the last ones that I have on here are similar, except that now we're doing secant, cosecant, or cotangent. So we just have to remember that. So I just added these in a separate thing. So on number 9, is secant by itself yet?
Yes.
It's almost there. We have a negative in the front that we need to get rid of, but it's very close. So we'll divide by -1. Notice how they asked the question. It goes from 0 to 360. So are we going to be doing degrees or radians? Y'all can mouth it. Is it degrees or radians? So someone said the second one. Yes. No. We're going to be using degrees, right? Because 0 to 360 is degrees, not radians. So we're not going to use pies in our answer in this problem because they asked for this. So this means our answer will be in degrees. Do we have to have a plus 360 in or a plus 180 in for these problems? Is that a yes or no? Once we do it, are we going to have to do plus 360 in or plus 180 in? No, because it doesn't say all solutions. This just tells you go from between 0 and 360. That means go once around the circle and write down all the answers. All solutions is when you do the plus 2 pi or the plus 360. Okay. So let's find when secant is -√2. Secant is 1 over cosine, right? Yep. Are we where we flip over the x? So let's find x's with √2's in them. And it's negative. So I'm going to suggest, or I'm going to guess it's this one, right? This is a cosine with a √2. And it's negative. And here's another one. If I flip that over, I'm going to double check and make sure 2 over √2 with the negative. Got to rationalize it. That's going to be 2√2 over 2. Your 2's cancel, and that is -√2. So I did pick the right ones. That's 3 pi over 4 and 5 pi over 4. Oh, but I'm in degrees. 135 and 225. So theta, 135 and 225. Doing like secant and cosecant and those problems are pretty easy when you have the √2's or the √3's in it, because it kind of helps you just to find those. All right, does 10 look like a doozy to you guys? If you saw number 10, would you be like, yeah, I want to do that problem? No? Yeah, I wouldn't either. I would say, no, we got fractions, we got a mess. But what I want you guys to do when you see problems that are set up like this, where you have 2 numbers and then divided by something at the bottom, before you start doing anything over here, I want you to put a 3 underneath both of these, and we're going to split them up and simplify. Okay, you know, if you've got a number underneath 2 things added together, you can make that into 2 fractions. It's going to make this a lot more manageable. So -9 over 3 plus √3 over 3. So when you see these problems, split them up. Now we'll be able to simplify a little bit better. What is -9 over 3? That's just -3. So we have -3 plus cotangent theta equals -3 plus √3 over 3. If I want cotangent by itself, what do I need to do? Add the 3 to both sides. And those 3's will cancel, and those 3's will cancel. Now we're looking for when cotangent is √3 over 3. Cotangent, remember, is x over y. So let's find out where x over y is √3 over 3. So this one is 1 over √3. This one is √2 over 2. √2. Oops, sorry, I switched it. I did y over x. This is √3 over 1. Sorry. This one is 1 over √3. All right, that just simplifies to √3. This simplifies to 1. Is this going to be, I got to rationalize this one. All right, so I got my √3 over 3 at 60 degrees. I've got to find another one where it's positive, where I've got the 1 over √3. I think it's in the third quadrant, isn't it?
So at 60, how is it √3 over 3?
Because it was, when you do x over y, that's 1 over √3, because the 2's will cancel. And then I rationalized it with a √3 and √3 on top and bottom. So that becomes √3 over 3.
Okay.
I'll make it a little bit bigger. It's hard to see there. So I have to do √3, √3. So that's √3 on top. And then this makes positive 3 on bottom. √3 times √3 is √9, which is just 3. So that's 60 degrees in quadrant 1. And then where we have that, I think it is also, yep, it is 240. Because -1 over -√3 will be √3 over 3 as well, because the negatives will cancel. So 60 and 240. So I always just go around and test out my x over y, see which one will give me that. Obviously, it wasn't the ones at the 45s because those had √2s in it, but you just look at the ones that have √3s, test them out until you get that. All right. That is all for the notes today. You guys, most of it is just getting the trig function by itself, finding it on the unit circle, and remembering if you need to do plus 2 pi or plus pi. 2 pi in or pi in for those. So tangent and cotangent just get a pi, and the other 4 get the 2 pi in.